Welcome back after a break. We are on a last session before the lunch break, and together with me are Martin Förtsch, Thomas Endres, and Jonas Meyer. The guys are from TNG Technology Consulting Company, and they will show us how to use AI in social media in a presentation with very intriguing title, The Shitposting AI. Guys, the floor is.
Thank you so much. Thank you so much for having us. Greetings from Munich and welcome to the Shitposting AI, where we will present to you today an ironic solution to fruitless online debate. I'm sure you've all had online debate before, but before we start into that, let us give us a couple of minutes to briefly introduce ourselves. I'm not here on my own today. Today with me here is Thomas Endres. Thomas, tell us a little bit about yourself.
Yes, so my name is Thomas Endres. I studied computer sciences, and after my studies, I joined TNG. This is already 13 years ago, and about 10 years ago, Martin and me, we created the innovation hacking team. And innovation hacking is all about innovative new showcases, innovative technologies, and we're trying to show you what is possible with today's technology. And today we're going to talk about one of these showcases.
Exactly. With us here today, not visible, but in the chat with you is Martin Förtsch. He's going to be having a look over the chat. He's going to be answering your questions. He is also a principal consultant at TNG. He also, as Thomas mentioned, founded the innovation hacking team. And then the third person, the guy babbling all about stuff, is me, Jonas. I'm actually a senior consultant now, so these slides are a little bit outdated. But yeah, I work at TNG also in the innovation hacking team. And what exactly is the innovation hacking team? Thomas briefly mentioned it. Well, it's a team within TNG that creates prototypes that showcase innovative technologies. And we go out there and we show them to the world like we're doing today. By the way, what you see on the right, that's a QR code. If you scan that, you'll come straight to our website. We do this throughout our presentation where we sprinkle in QR codes for more in-depth information of what exactly we're talking about right now. So what do? We do, for example, real-time deepfakes, as you can see them here. These are deepfakes that run in real time, and they can convert any face into basically any face for all those moments where you just can't get enough of yourself and want to watch TV with Jonas on every single head. And you might ask yourself, why do we do this? Well, because first of all, these projects are fun. They're a great way to also learn about innovative technologies before our customers ask for them. And then also, of course, because we want to go out there and share this knowledge and the knowledge that we know with the public. So basically here you can see Thomas in a TV interview talking about deepfakes. And here's another example where Thomas is in a TV interview talking about deepfakes, and here's another example of Thomas in a TV interview talking about deepfakes. So you see, we have a lot of experience going out there, showing our things, and one thing that comes with going out there and talking about stuff that you care about is, well, there's always a public reaction in form of comments. Here you can see the comment section from like a German website called Heise.de. It's an IT website, and we're just going to quickly pick out one of those comments here. It's in German, so I'm going to roughly translate. Oh, the employees of TNG Consulting, which is not what we call it, by the way. They tape their cams on their notebooks with tape. How I know? Because everyone does that. I still think we did the Amish people wrong. Well, we don't really know what that has to do with deepfakes, but anyways, our typical reaction is that we have to reply to that. We have to bring our point out there because we don't want to just surrender to this huge piece of injustice. And we did this for a couple of years and months, and we figured out, well, it takes a lot of time, and we kind of asked ourselves why, and we often found that, well, we can reply to that shitpost that was posted, and then the shitposter will again reply. And so we kind of thought to ourselves, well, this is kind of what we call the shitposting circle jerk, where you have the shitposter who shitposts, us replying, and then the circle closes and it goes on forever and forever. And if you've ever discussed online, then you'll also know that this conversation will go on forever because it's absolutely fruitless. Nobody ever changes their mind online. And at the same time, it's very exhausting because, well, just of the toxic nature, how online discussions generally work. But yet we feel that they are necessary. So we as IT guys, we thought to ourselves, well, this is a big problem that we have that we just can't get rid of. Maybe we can automate that. let's just like put a bot in our stead that will then reply to the shitposter. The shitposter will still reply to us, but the bot will take care of that, and we can just do something proper with our time, for example, work. But then we figured out, well, this is not just our problem. This is actually a huge problem. There's also a shitposter on the other side who's wasting all of his time. So the only way that we can go around this is take the human completely out of the loop. And this is the basic idea of the shitposting AI. So in the middle here, you have a floating NLP AI brain that, first of all, creates a shitpost and then replies to it and replies to that reply and goes on and on and on forever. And we don't have to take part in this. We can just keep working. And even the shitposters themselves can now do something proper with their time. And you might now have a look at this and think to yourself, well, I don't really feel represented by this floating NLP brain. It's kind of uncanny. And that's something that we thought of too, because we kind of have to rehumanize this whole floating NLP AI brain kind of thing, make it look human again. And what better way to do this than with robot heads? And that is basically going to be our physical representation in this AI conversation that we're having. And that is exactly what we want to talk to you about today. And so let's get right into that. So first of all, we're going to do a brief introduction where we talk about, well, what's the basic idea, then what is NLP and what is neural networks, basically. So the basic idea here is we have this floating NLP brain that's going to come up with a social media comment. That social media comment is going to be sent to one of our beautiful robot heads. That robot head is going to read that out and tells the floating AI brain that it's done, and that generates a new comment, and we go on and on and on. So that's what we want to achieve today. So let's get to our first question then. If we have like this floating NLP brain, what is exactly NLP? Well, NLP, that is basically where linguistics and computer science meet. Like we IT guys, we love our Venn diagrams. And this basically means, well, whenever you do some kind of processing of human language, be that text or voice data on a PC, that is NLP. So that can be, well, what you're using every day on your smartphone with your smart home assistants, where you ask it a question, it comes up with some answer and like reads it back out to you. But you can also do things like automatic summarization of documents. You can also do sentiment analysis. And if you've not been living under a rock, you know that now there's ChatGPT and GPT-4 that can do all of these things for you. And the interesting thing is, well, what we're talking about mostly here is GPT, ChatGPT, and today we're also going to be talking about some form of GPT. All of these are neural networks. So we want to have a quick look at what exactly a neural network is. Thomas.
Yeah, so let's see how and we'll start from the beginning. So in the beginning, there was the logical neuron, so you can see it here. And this is basically just transmitting information. So you have one neuron and you want to transmit some information to the next neuron. And in this case, you want to have some kind of, get some kind of stimulus from the previous neurons. And if this stimulus is high enough, and if the activation reaches a certain action potential, then the neuron will fire and it will give the information to the next neuron. And if it doesn't, then you have a failed initiation and nothing will get transmitted. So this is basically how one neuron works in the inner workings. And there was some mathematician who thought, hey, we can easily press that into a mathematical model. And this is what you can see here. So you have first of all, the input information that you get by the axon. So this would be something in the mathematical model like an x0. Then you multiply that with a weight, which is the importance of the information that you get. And then you also add something like a bias, which is how reactious such a neuron might be. You just put an activation function in this. So for example, for the biological neuron, this would be something like a cutoff function. And then you are good to go. And if this is, in the case of a cutoff function high enough, then the neuron fires, and otherwise it won't. So let's have a look at not just one neuron, but a few of them. So here you can see a beautiful animation that cost us a lot of money and which shows how such a neuron works in the inner workings with multiple of these inputs. So we have one input which is less important with 0.7, or I have a more important one. And these three input neurons that we get here are then weighted, they are summed up, then they get the bias, then we have the activation function. In this case, it's not a cutoff function, but rather a linear function or rectified linear unit. And then the information is sent off to the next neurons where they will be processed in pretty much the same way. All right.
Exactly. So now we know how a neural network works, or an artificial neuron. The only problem that we have here is that those things work with numbers. You saw we have numbers as inputs, but now we're working with text. So how do we get from text to numbers? So let's have a look at this example that we have here. Just for the sake of the example, we have the sentence, Jonas Meyer is so nice, that you might or might not agree with. And what we're going to do to this now is called tokenization. So we're going to split it up into words or subwords. In this case, it's going to be Jonas is a single token, Meyer is a single token, is a single token, so and so are two different but the same single token, and so on and so on. And then we can just simply assign each and every token a number. In this case, Jonas is going to correspond to a 4, is going to be a 1, and a so is going to be a 3. And mind here that both of the so's being identical have also the same identifier. So finally, we turned our sentence, Jonas Meyer is so nice, into a sequence of numbers being 421337. And of course, everything is much more fun when we have a live demo, and we have one here, and we can now actually check what our prompt from earlier would give us. So we're running tokenization on Jonas Meyer is so nice, and it splits up Jonas into 2 subtokens. Then we have Meyer as a token, and down there you can also see the token IDs, which in this case are quite high because we're using the byte pair tokenizer, which is exactly the tokenizer that we're going to be using for GPT later. Thomas, do you want to do another example, or should we move on?
I think we should move on. We don't have much time.
Let's go. We don't have too much time. That's exactly right. So what we can do now is we have now turned our sentence into a list of numbers. And one neuron by itself is not too interesting. We have to stack them to get what is called a neural network. And here you could now assume we want to do something like spam classification on, for example, the sentence Jonas Meyer is so nice. What we do is we take this input sequence, we put it into our input layer, which has a fixed size. In this case, it's 31, which isn't a problem because we're just going to pad everything else. Is the screen sharing still on, by the way?
It's working.
Okay, it's working, cool. And then all of that information from the input layer is going to go into the first layer, where we're going to have a bunch of neurons. The outputs from that layer are going to go as inputs for the second layer, and so on and so on. And in the end, well, we will get some kind of a result that tells us, wait a minute, it's 0.99 spam, which means a 99% likelihood, which we of course know is not the case because we have ground truth data. And so what we can do now is, if our neural network misbehaves, we can do what is called training to kind of get our output closer to the ground truth that we know that we have. And all of that is pretty easy, right? Well, kind of not really. There's a lot of more stuff that we can't really talk about because we only have 30 minutes today, but it's a little bit more complex than that. And if we have the time, actually, we might dive into a little bit of that when we talk about GPT. So with that out of the way, we now know what NLP and AI is, and now we're going to jump straight into how to actually create social media comments. And if you remember, that's just a part of this floating AI brain. And what are we using for this, Thomas?
Yeah, we had a look at the internet and found out that already a few years ago, there was something which we could use, and this is from OpenAI. Pretty much everybody knows these days what OpenAI is about because of ChatGPT, but a few years ago it was not that common. Back in the days there was an AI called GPT-2, so this was the predecessor of what we now have with GPT-4. And in their advertisement they already stated that we can also imagine the application of these models for malicious purposes, including the following: automated production of abusive or fake content to post on social media, and also something like automated production of spam content. So, and this is why we thought, okay, this is perfect for us. This is exactly what we want to do. And that's why we used it, basically. And so we had a closer look. So what does GPT stand for, by the way? It stands for Generative Pre-trained Transformer. There are 3 words in it. First of all, generative, so the AI is creating text. It is not classifying or doing something like that. It is a pre-trained neural network, so it comes with knowledge of the internet. It was basically trained with lots of the internet, so it basically is right all the time. And it is also a transformer architecture, and we'll have a look at this kind of architecture in a moment. So but before we do this, let's just have a look at a demo and see what GPT comes with if we just put it out of the box and try it right away.
Exactly. So what we can do now with GPT is what is called next word prediction. So we give it the stem of a sentence, for example, the Warsaw IT days are. And now we're just going to let it run over this. It's going to run GPT, as you saw. Before that, we ran the tokenizer. And now it tells us the Warsaw IT days are in the year 2039. A Polish man and a Romanian woman celebrate one of their children's birthdays. And we can create another output. It gives us something else every single time. I'm sure most of you have probably played it with GPT at this point. This is an older version, so obviously it sticks to the truth quite a lot more than it does right now. But you can see we get some kind of text that seems legitimate, that doesn't necessarily make sense, which is perfectly fine for what we want to do here with our shitposting AI. So what exactly does GPT do now, Thomas? How does it work?
Yeah, so let's have a look at how we create these sentences. So it's called next word prediction, or to be more precise, autoregressive next word prediction. So we're putting in at the beginning just the word Jonas. We're padding everything else, and then this is the beginning of the sentence. We run that through GPT, and we get an output, which is Maya. Then we put in the Maya at the input again, and then we have Jonas Maya in the input layer, and we can predict the next word, which would be is, and we are going on and on and on like that. So, and we're getting Jonas Maya is a dork, and when we are finished with the sentence, it will predict end of sentence token, and with this we can then see, okay, our sentence is finished, it is perfect, it is true, Jonas Maya is a dork. So yeah, we can continue with that. But Jonas, how does it look like in the inside? We have a huge black box here.
Yeah, we have a huge black box, which we're not going to clarify too much because we only have 10 minutes left. But the secret sauce of GPT is, and of all transformers, is how it uses mass self-attention, and that's what makes it so powerful. We could go on for hours here, literal hours, but we don't have time, sadly. So we have to skip right ahead on to how you actually go about training GPT to do what exactly you want it to do. Because, of course, we don't want just the general GPT in this case. We want something that is trained on social media comments. So remember how we could do autoregressive inference here to do next word prediction. We can also take all of our words, we can just fill all the input and put all of that through at the same time, and it will give us a prediction for what exactly the next word might be. And in the case where we put in your deepfakes are shit, well, it might think that the next word that is logical is mom in this case, and a couple of other nice words. But of course, we know, well, what the next word is. We know that from the input sequence from our data set, and we can compare that against the prediction of GPT. And we can see where it is wrong, and we can train it to basically be better at that. We only need a data set for that. Then, of course, the big question is, well, what kind of model do we use for this? And at the time that we started this project, there were two big things. There was GPT-2 and there was the bigger brother, GPT-3. The big problem for us is, well, GPT-3 was only available behind a closed API. And we really wanted to have something that we could train ourselves and that we could also run locally. So GPT-2 it is. And that leads us to the last remaining question. Well, where do we take the data from, Thomas?
Yeah, there are lots of social media platforms where you could take the data from, but we find two which are especially aggressive, and these were Twitter and Reddit. And we have also found some scraping mechanisms for that, or some APIs with which you can get the data. So let's have a look at Reddit. So for Reddit, it's called Python Reddit API wrapper. You can see it in here. So you basically can just get the list of comments from all subreddits And this is pretty fine, but unfortunately, for most cases, this is not appropriate for us because it is not about discussion, but rather about porn, and we don't want that. So what we rather want is a curated list of things that we where these discussions take place, and this is why we filtered the subreddits, and in this case we are using the topics like politics, change my view, unpopular opinion, shower thoughts, news, not the onion, political discussion, world news, or mechanical keyboard, of course, because we thought that would be the topics that get the most controversial discussions out of it. All right. And then we also have an API for Twitter. I'm not going into details there as well. The problems with this was rather another one because here we have discussions, but we are pretty limited in our abilities. So we can only scrape so and so much data at a given point in time. But that's fine for us because we want to scrape our data continuously anyways. So let's have a look at how this works. But before we do that, we want to have a look at the closest structure of such a post. So these are somehow tree structures because we have replies to replies, and things like that. And we need to get them flat. And this is what we did here. So basically, we are just putting in end of comment tokens between all these different posts. This somehow will remove a bit of structure between these posts, but that's okay for us since there was not much structure in it anyway, so we can just go on like that. And with this flat list, we can now train our neural network. The only thing that we have left is we need to continuously train it, and therefore we need a mechanism to not just scrape and train at the same time, and this is why we use different data buckets. So for example, we are scraping into the first bucket in the first day and training from every other bucket that we have, and then we go on for the second bucket and scrape into that on the second day and train again from every other bucket. And we can go on like that for 14 days, and then we start over at bucket 1 again. All right.
Yeah, and with that, we now have a beautiful shitposting GPT that can now start its own conversation, or we can just seed it with something. So for example, we can just seed it with the very popular topic on Twitter and Reddit over the last years. COVID is a thing. And if we now just let it run over that, it will start coming up with replies. It will start, discussing with itself. So you can see, well, it's kind of sticks to the topic, has some very bad arguments. And here we have a reply to that first reply. And it's basically just going to continue rambling on forever. It's going to make up fake links, just like people on the internet do. It's just going to make up false facts. It's going to be very rude at doing so. And so this is just going to be able to run on and on and on and on forever. It also changes topics from time to time. We're going to have a look at one more, and then we are going to move on to the other two topics that we have. Yeah, healthcare. That's what we care the most about. All right. Okay, so now we have basically solved creating social media comments. Now we still have to create human voices that read out our text and build robot heads, and we're going to go over that pretty quickly. So creating human voices is for the part where the robots speak, and you might know like text-to-speech approaches from your home assistants. For example, we had a look at the one used by Google, which is called Tachytron, that doesn't really look like this, but more like this. It's basically a two-stage approach that first generates your text into a so-called Mel spectrogram, which tells you which frequencies occur at which point in time. And then we have a second neural network that turns that into a waveform. And you can use that to train, for example, voices like the one of Arnold Schwarzenegger.
The meaning of life is not simply to exist.
Which is not really what we want because we don't want to get sued. So we tried training our own, and it kind of sounds like this.
Control of the Senate. I never really understand why Republicans ever want to support anything the other side says they do. It wasn't really a Twitter update until I was in for the ride back from.
So Yeah, so it doesn't really work that well. Thomas already told you we don't want to be making porn, so we decided to instead take something off the shelf that has voices that are less critical. For example, we have Cocky AI TTS with Glow TTS that runs locally, or we can just use the power of the internet and run something in the cloud using, for example, the AWS servers, Amazon Poly, where we get neat little voices like this one.
Hi, my name is Joanna.
And in all kinds of languages as well.
Salut, je m'appelle Léa.
So now we can read out our social media comments. That's this. And now we have to have a look at, well, the final, very important part of building robot heads. That's the part of the robot heads. And as you can see in this video right now, well, we're actually pretty experienced when it comes to building robots and dealing with robots. So we thought, let's just build our own. The basic idea here being the core is a Raspberry Pi that connects to the internet. Then we have a speaker attached to that, and then also we want some nice lighting effects to be more human. So we want red glowing eyes, and also for like every single human that you know, we have like a spinning light circle on the forehead that indicates whether you're actually thinking or not. So the core of these things is going to be these beautiful glass headphone mounts. And we thought, okay, let's use those to give us a rough shape and then just fill them with the electronics. For that, we 3D printed some beautiful mounts. We just stacked everything on there, built some beautiful things. And well, yeah, our expectation was to kind of get like something similar to this, something very sci-fi like, and we kind of got something like this. And don't worry, we're going to have a look at exactly how these things look like in the flesh. I have them here with me later. And now this brings us to the last topic of putting everything together. So connecting the AI brain that we have here with the voices, with the robot heads. And this comes up with the first big problem, which is, well, NLP GPT in particular needs a lot of computing power, which we don't have on a Raspberry Pi. So we decided to do like a client-server architecture, which is actually pretty similar to what the concept was in the first place. So we're going to have a server that runs GPT, tells the head to think. We then run TTS as well, so text-to-speech, on the server. We then tell the head to stop thinking and send the sound file over, tell it to play it. It's going to play it when it's done. It's going to tell us, well, I'm done now. And then the circle is going to start from the beginning. GPT is going to start running, and we tell the next head to think. And we also built a beautiful messaging front end for it that kind of looks like Telegram. We thought it might be a good idea to run this live until we figured, no, this is absolutely not a good idea. But with that out of the way, the last thing to do is to really just start the demo here, because we have them with us here live in the studio. And I have now the pleasure of showing you the beautiful heads that we have here. And I'm hoping you're picking up some of the beautiful inferences. So I just plugged in the heads. You can see the spinning lights in here. And in a minute or two, they will have booted. Well, not in a minute, but like a couple of seconds. And then they will just start babbling on about basically whatever. So let's give it a couple more seconds. In the meantime, if you have questions, feel free to post them in the chat. Martin is there to answer them for you. And let's see. Okay, they booted up. And we should be getting...
You know that when you wipe your ass with it, but if a dirty mask doesn't look like this after one day and then there's not much dirt on either side after. Also, why are we talking about a wet wipe? Is everyone?
Yeah, what a beautiful reply.
That looks like some sort of funky shit coming out from behind the sink sink. Maybe you need to take a fresh dry one ASAP.
I used bidets but never once came across that they looked anything like this at all. Looks like you tried and failed.
Yeah,
Not
so
sure what is going through your system, but
there you have it.
it'll help.
There you have it. This is the solution that we've all been waiting for, robot heads discussing about bidets. The question, though, is like, what does the future hold for us? So if you remember GPT, well, first let's talk about what we didn't talk about today, which is the part where you as a human could interact with these heads. We decided to not do that because that's just like a waste of time. But what's in the future? We talked about GPT-2. We also briefly mentioned GPT-3, and now you might know that as GPT-4. Well, we do other projects with that. For example, we built AIslides.com, which is a beautiful website where you can go and watch beautiful, completely AI-generated slides. So all the text, all the images are generated by AI. We just have to provide it with a topic. And so there's also a QR code here if you want to check that out. With that out of the way, this is everything that we have for you today. It has been such a pleasure talking to you today, and we're right on time, actually. So if you have questions, I'm not sure if we have time for that. Maybe we can do a couple of, let's see.
Okay, thank you guys for your presentation. We have a few minutes of for a Q&A session. So if you have questions, please post them on chat. I will give you a few moments to do that, and I will remind you that you can rate this presentation, this talk, using the stars under the video. And also today we have IT job fairs that you can take part, meet the employees, talk with them about their offers, or just check what market conditions and what they are looking for. Still, I don't see any new question on the chat.
That's
Nothing
good.
changes. So the presentation was so good that no one knows what about to ask you guys. Thank you very much.
Hungry. Thank you so much for having us.
Hungry. Okay. Thank you very much.
Thank you very much, and see you after the break.
Have a good one.
Bye-bye.